In this problem, we're going to look at what the maximum fraction of a submarine's volume can be steel in order for the sub to still float. The assumption is that the specific gravity of the water is 1, because its density is that of water, and the specific gravity of steel is 8, and the specific gravity of air is about 0.001, because air is about 1,000th the density of water. We know that if it were all steel, it would sink to the bottom, and if it were all air, it would float and go above the water. The question is, what fraction of it can be steel and have it still be able to float? We're going to use Archimedes' principle to solve this problem, and what Archimedes' principle says is that the weight of the displaced fluid is equal to the buoyant force on an object. So if the object is floating, then that's also equal to the weight of the object. The weight of the displaced fluid when the submarine is floating is the mass of the fluid times gravity. The mass of the fluid is the density of the fluid times the volume of the submarine. The weight of the submarine has two parts to it. That includes the mass of the steel and the mass of the air, each times gravity. So we'll use x as the fraction of the volume that is steel, and 1 minus x is the fraction of the volume that is air. So what we have is the weight of the displaced fluid on the left-hand side is equal to the weight of the submarine in terms of its steel weight and its air weight added together on the right-hand side. Now if we take all of these terms and divide by the density of water times V times G, this is the same volume in each case, the way we have defined the terms, and of course the density of water and gravity are constant. Then we end up with 1 on the left-hand side is equal to the fraction of the volume that is steel times the specific gravity of the steel, plus the fraction that is air times the specific gravity of the air. Rearranging this equation, we can solve for x in terms of the specific gravities of the air and of the steel, and then we can plug in numbers and solve for the maximum fraction of the submarine that can be steel. In the end, we find that 1/8 of the volume of the submarine can be steel in order for it to still float.